This is lesson 5.3 properties of logs. Let's just get right into this. I'm Math Boy. If you enjoyed this video, go ahead and leave a like. If you don't want to see this, close out of the tab. Okay, so the first logarithmic property, we're just jumping straight into this. First one is, and this lesson is pretty much just these 5 properties and then practice, which I will do. The first one is change of base, and I don't know about you, but I have a calculator that you could just type in the base and it'll be like, oh yeah, you're that's fine, we'll calculate that for you. And actually, hold on, let me see if my phone calculator will do that. It will actually do that. Wow, that's cool. But a lot of calculators don't do that, and so we need to use this change of base. Base. I'm gonna call it that from now on. We need to use this change of base formula, which is, we have a log, so log base a of x equals log base b, which is the base that we want to change it to. So if we want to change it to log base 10, b will equal 10. So log base b of x over log base b of a. And I just think of that like, if this logarithm value is going to be a whole number, x is going to be greater than a. And so this value will be a whole number. That's just how I think of it. How I know x is on the top and a is on the bottom. Because for it to be a whole number, x has to be greater than a, which means x will have to be on the top and a will have to be on the bottom. That's how I remember it. And so let's do an example. Log base 3 of 4 equals, I'm going to change this to maybe, let's say, log base e. So I'll abbreviate that ln, 4 over ln 3. And that'll always work out like that. I don't have a proof prepared for you. I said that in the last video, but then I actually did. So this time I actually don't have a proof prepared for you. Let's go on to the next property. Okay, so this property is called the product property because there's things being multiplied, and we're gonna simplify it. So log base a, I'm just gonna write log because I'm lazy. Log of xy, and that can be base a, I'm just lazy, equals log, I'll just write a just in case there's anyone who doesn't have the volume on. Log of base a of x plus log base a of y. And I actually want to prove that this works by plugging in test values. So we'll have hypothetically log base 2 of 16. You know what that is. That's 4. Because 2 to the power of 4 is 16. Wait, right? 2, 4, 8. Yeah, okay. 2 to the power of 4 equals 16. We know that's 4, but we're going to simplify this. So log base 2 of 4, because 16 equals 4 times 4. So log base 2 of 4 plus log base 2 of 4. And then we can simplify that even further to log base 2 of 2 plus log base 2 of 2 plus log base 2 of 2 plus log base 2 of 2. That's 1 plus 1 plus 1 plus 1 equals 4, which is the same thing that this equals. So I think that shows that it's right. And this comes in handy when we have something like log base 2 of 60, let's say. It says write this in terms of log base 2 of I'm trying to think. Log base 2 of 15 and log base 2 of, write this in terms of log base 2 of 15. So we do log base 2 of 15 plus log base 2 of 4, which we know is log base 2 of 15 plus 2. And that's where you'll use it most, and problems where you have to expand logarithms. Let's jump into the next problem. This video seems like really boring because I'm not graphing anything. I'm not used to it. Thought you might want to, hear my inner feelings. Quotient. We're gonna do quotient property. And I wonder if you're fine if I don't write the base A. I mean, no one watches these anyways. Log base A of x over y equals log base A of x. Guess what this is going to be? If the multiplication was plus, guess what this is going to be? 5, 4, 3, 1. It's minus. Log base A of y. And once again, that'll be useful when it's just like expanding a logarithmic function, and write this in terms of log base A of 3 and log base A of 2. Like, if we had log base 6 of 3 halves, write in terms of log base 6 of 3 and log base 6 of 2. Of 3 minus log 6, 2. And then I'm going to actually do a test value for this. So let's say log base 2 of 4 over 2. 4 over 2 is 2. Log base 2 of 2 is 1. So we know the value of this. So let's write it out in this property we've used. Log base 2 of 4 minus log base 2 of 2. 2 minus 1 is 1. And we also got 1 here. So that's great. Property works. We're happy. This video, I have mixed feelings about it. This lesson's just these 5 properties and nothing really else. Oh wait, it's only 4 properties. Oh my gosh, we're almost done. Don't worry, I'll do like 2 examples so it'll seem long. Okay, we have the power property now, and you probably can know that you can probably tell from the name that there's going to be something inside the logarithm that's being raised to a power. Let's just do this. Log base A of x to the y. Not the value of log base A of x to the y, like all that to the y. Just log base A of x to the y, the value of x to the y, equals y times log base A of x. That's it. So if we had and once again, this will be useful, write this in terms of log base A of, I don't know, 3, and it's a 9 in there, and it's a log. Okay, write this in terms of ln. Here, I'll just write this out so that you know what I'm saying. Write this in terms of ln 3. And there's 2 ways you can do that, and this will just show that this is true. You can write ln of 3 squared, bring the 2 in front, 2 ln 3, or you can separate that into ln of 3 times 3, so ln of 3 plus, because you separate them, ln of 3, which is the same thing as 2 ln 3. So you get the same answer either way. That should help you know that this is a true property. And that's about it for new material. Sorry if this is a little boring. I'm gonna go to practice now. I can graph something if you want. Don't think you want that though. This ugly thing that we are going to fix because I don't like this. I don't know about you, but I don't like it. So we're gonna rewrite. First, you wanna do all the division first. So we're gonna separate that division. So log base 3 of 2x, all of it being squared, not just the x, because that makes a difference, minus log base 3 of 36. And then I'm going to work with the left side first, because I can see very well what I need to do over here. So bring the 2 out in front. Actually, do we want to do that yet? I'm wondering if we want to. Yeah, we'll do it now. Yeah, we'll just do it now. I'm deciding what order I want to do this in. But if you do this, you'll have to remember. I'll show you what I'm talking about. then you have to remember that the 2, when we separate this, you have to remember that the 2 applies to the 2x and the x. I guess what I'm trying to say. 36 is 3 times 12. And we're going to separate that. Now we're going to separate a bunch of stuff by addition. Oh, whoa, what did I just do? Okay. 2 log base 3 of 2 plus 2 log base 3 of x minus log base 3 of 3 plus base 3 is that. 12 can be written as 4 times 3, or 9. Wait, yeah, so then, whatever we originally had, 36 can also be rewritten as 9 times 4. I think I'm just going to stick with that, because it's less writing. Oh my gosh, I'm making this so much worse for myself. No, let's just go back to stick with 3 times 4 times 3. So log base 3 of 3, log base 3 of 3, log base 3 of 4. That's 2 log base 3 of 2 plus 2 log base 3 of x minus log base 3 of 3 is 1 plus log base 3 of 3, which is 1, so minus 2. Ooh, and actually, I think the minus applies to the whole thing. So minus 2, and then minus because the negative distributes. So minus 2, and then minus log base 3 of 4. Bet you liked that problem, didn't you? So you get for asking me for examples. Time for the next problem. Welcome to problem number 2. And I'm just gonna say, I should have said this earlier, but you know, I was sort of feeling a little bit sad earlier. I don't know why. I feel sad for no reason sometimes. Is that normal? I think it's normal. Anyways, I was thinking earlier, like, no, I was doing something earlier, and I'm probably not going to get 6 videos out this weekend. I'm serious, I'm going to record a lot this weekend. I'm not going to get 6 videos out this weekend. I'm only going to get out 5, and it's all the odd ones out's fault. Because I was watching his live stream of him playing Tetris, and it was like 2.5 hours or something, and it wasn't live when I was watching it, but it was a live stream. He's a good guy. Go watch the Tetris video. He's okay. He's pretty good at it. Anyways, back to this video. I'm gonna split this into 3 parts, because I sort of have to deal with one part before I deal with the next part in this particular problem. So, the first thing that I see that's really upsetting me is this 2. I'm gonna move it up here. So, I have log base, sorry, in fact, I'm just gonna say base. Log base 3 of 2x squared, and that's this 2x squared, not the log base 3 of 2x, that value squared. Gotta make sure you know that. Plus log, because I actually had a question like that on one of my quizzes, where it was like log base 3 of 2x, but only the x was squared, so you couldn't take the 2 out to the front, and I knew that. No, it was 5 root x, and x root square root of x is x to the 1/2, and so you couldn't take the 1/2 out to the front because the 1/2 didn't apply to the 5 and the x. But that's why I keep saying that. And already started writing it out. Ugh, there, I'm lazy. Okay, and then that's the same thing. I'm going to distribute that power of 2, because it's one term, I can just distribute it into each part of the term. So log base 3 of 4x squared, and that squared is only applying to the x, plus log base 3 of 60.75 minus log base 3 of x. And now what I'm going to do is I'm going to leave that minus log base 3 of x alone for now, and do the log, I sort of want to do the sideways, but I sort of don't. Why do I use up so much room? Log base 3, and I'm going to combine that, 60.7, hold 60 and 3 fourths, that's 243 over 4 times 4, cancel out, log base 3 of, I don't know why I still have to do that. Well, I mean, that's still not very easy. Log base 3 of 243 x squared minus log base 3 of x. Oh my gosh, I'm so sorry. Oh my gosh. Log base 3 of 243. And I'm separating this for a reason. Normally, you would, well, you still have to write over, you would still have to condense that subtraction sign normally, but 243 is a power of 3, and I know that because I made the problem. If I didn't make the problem, you would have to figure that out on your own. X squared. Let's just separate them so that it looks better. Plus log base 3 of x squared minus log base 3 of x. And log base 3 of 243 is 5, because 3 to the power of 5 is 243. I checked it like 5 times on Google, I'm sure I'm right. So then 5 plus log base 3, and I'm just going to do this all once. I'm going to combine these two terms on the right side of this equation over here in one step, because I don't have a lot of room, of x squared over x, but x squared over x, if you remember that, well, you know that this, and then the x's would cancel out, so that's 5 plus log base 3 of x. And I know I could have done something like, if I had a plus sign next to the log base 3 of x instead of a minus sign, I could have made log base plus log base 3 of x. That's my answer. And I know I could have made it something like, with the minus sign, I could have made that a plus sign next to the log base 3 of x, so that, by the way, that's where I got that. If you are doing this visually, I could have done plus log base 3 of x instead of minus log base 3 of x to, make it 5 plus x, but boring. Wait, did we do that? Oh wait, no, I couldn't have. I got my logarithms mixed up. I'm so sorry. Because, oh wait. Okay, yeah, so I got it mixed up, sorry. I couldn't have done that. Don't know what I'm thinking. Anyways, if you enjoyed this video, leave a like. It would be greatly appreciated. Also, a really good idea, consider subscribing. I'm posting a lot of videos this weekend. If you don't want to miss any, then subscribe and turn on notifications. That's more important than subscribing, but you need to subscribe to turn on notifications. So do that. Have a great day. Be good at math. Don't make stupid mistakes, like I almost did here, where the red is. Was my answer. And stay good life. Bye. This is the first video out of many this weekend. I don't know how this is going to go.